Hello. So last time we learned about aggregation functions. Today we are going to learn about group by, which is related to aggregation functions. So with the aggregation function, if we remember like sum, what happens is it aggregates the whole table into one row, right? That has a summary metric like count, sum, like this one, average, and stuff like that. But the question is, what if we don't want to aggregate across the entire table, but only part of the table, right? So for example, if we look at here, I want to see what the total revenue of each type of restaurants rather than the total revenue of just all restaurants. Then what I can do is I can use group by, which is what we're learning today. So you can also say, oh, why don't we just use where? Filter, for example, for a specific type of restaurants. But here, what we can do specifically is imagine if there are multiple types of restaurants, like Chinese restaurants, Italian restaurants, and fast food restaurants. Well, I guess it's all fast food, but let's just say it's different kinds of restaurants. Then what happens is you're going to get multiple rows of different types. And then you're going to aggregate all of those rows of the same type into one table. So instead of only having one row where you have the sum of the revenue, you're going to have multiple rows depending on how many types of restaurants you have. And then you're going to get the sum of revenue depending on what type they are. Here's an example. And then here's another example, which actually yields the same thing as that. Instead of writing group by and then the column name, I just put the number 1, which is just the faster way of doing it. In case you're lazy and you don't want to type the column name, then you could just write 1 to indicate that you want to group by the first column. Usually that's how we write queries when we group by. We have the first few columns that we want to group by, because you can group by multiple columns, which I'll show in the future. Like imagine if I want to type and then maybe, what else can we group by in a restaurant? Maybe by area, yeah? You imagine if you had area here. So you were selecting area, type, and then you sum the revenue, then this is not going to work because you're going to have to group by 1 and 2. Because when you use group by, you either have to have columns that you're going to group by, and then you also have to have columns that you aggregate. You cannot have a column where you do not aggregate, nor do you group by, because that doesn't make any sense, right? So let's look at an example of a table where we do a group by. So here we have an example table, which is employee. So here you have the employee ID, here you have their names, here you have the department number, and then here you have their salary. So we call this query so that, as you can see, we are grouping by the department ID, and then we're averaging the salary to see which department has on average the highest salary. So this is the table we get. So as you can see, here are the department IDs. Department ID number 2, department ID number 1, and then department ID number 3. So as you can see, there are 3 different types of department IDs, which is why our resulting table will have 3 department IDs. And then what happens is you're averaging them out. So for 1, you're averaging these 2 numbers, which is why we get 3,000 using mental calculation. And then for department ID 2, you're going to average these 3 numbers, this one, and this one. So 3,000, 4,000, and then 4,500, and then it will yield 4,000. And then lastly, for number 3, department number 3, you're going to average these 2 numbers, which yields 4,250. All right, so as you can see, this is super useful. It's the same thing as what we learned last time with aggregation functions, but now we have another secret power, which is to group by, which allows us to compare different groups together. All right, so now what we should do is we should look at mode, and we should do a few exercises for us to learn about group bys. They're super powerful, and let's do it. All right, so today we are going to use the table SAT scores. In case you don't know what SAT is, it's a standardized test for American schools, I believe. And you have 3 separate, actually, you know what? Let's just look at the table. Select from, and then the table name, We run it. You have 3 different scores. You have the math score, the writing score, the verbal score, and the math score. I think that's what it is. It might be different now, right? So here, as you can see, this table, you get a school, right? Like Washington High School. You get a teacher, depending on which teacher the student has. You have the student ID, and then you have their scores for each of the section, writing, verbal, math. And usually what you do is you just sum up all of the numbers together to get their SAT scores, I think. Yeah, you get a number out of 2100, I believe. And then this is the hours studied, reported by the kid. And then, yeah, that's it. Okay, cool. The first question here is, which school has students studying the longest on average? All right, so you remember how to do average. You do AVG, and then what we care about is hours studied. Okay, so here, if you just do this query, right, like that, then you know what the average student, like how long they study. 100 hours, apparently. That's the average. But now we want to know for each school, which school has students that study the longest. So here you can add school, and then you can group by either one or school. It doesn't matter. I'll just do school for now. And then we run that. Aha. So as you can see, the hardest working students are the ones who attend Washington High School. Okay, so then the next question is, which school has the highest SAT score? Weigh the subjects equally, so we're just gonna sum it. Okay, so same thing. We're gonna group by school, and then we care about the highest SAT score. So I guess it's like on average, because we care about on average if the students are getting the high SAT score. Then we do SAT writing plus SAT verbal plus SAT math, and then let's call this average SAT score from tutorial.SAT scores group by 1. All right, we're gonna run this. So even if Washington High School studies the longest on average their SAT scores are not the highest. For example, Petersville has the highest SAT scores. Interesting. All right, so this is pretty much it, how you use group by. It's pretty simple. But let's have a little fun and get creative with group bys. So imagine if you care about what is the distribution of students' study hours. So this really depends on how you want to do it. For me, for example, I care about in buckets of 10 hours, right? So what I mean by distribution of students, it means you want a distribution graph. What a distribution graph is, usually kind of looks like this. This one too, you have buckets of numbers, and then the y-axis is basically telling you the counts of like how many people study in this amount of hours or stuff like that. There should be a better one, a more real. Oh, kind of like this. Distribution of colors, for example. How often, right? And this is the frequency. How often are things brown? How often are things red, yellow, green, blue, orange? So we're going to do the same thing, but instead is hours studied. The x-axis should be the thing we group by. So for example, hours studied. But then I want to group them by 10. So how do I do that? Well, I could divide them by 10 and then floor it, right? So then it kind of rounds them down and then remultiply by 10. So I don't want to have one bar for each number because that's not going to be that useful. I want them to be grouped by tens. So okay, so we got that as a number of hours studied. And then what we have next is the count, as in how many students studied this amount of hours. Okay, that's the number of students from this table. And then let's run it, see what it looks like. Oops, I have an error. Must appear in group by. Oops, I forgot to group by 1. Yep, number of hours. See, this is why putting a number for group by is useful, because you don't want to rewrite this whole thing. Technically you can, you could just copy paste this right here, and this would be the same thing. You could just run it and it'll be the same thing, but you don't want to rewrite it, right? So you could just press 1. I mean, you could just insert 1. Okay, just for visibility, I kind of want to see it from 0 to 200. So what I'm going to do is I'm going to order it by 1 also. So now I want them to be ordered, so it's a lot easier for me to see. Aha, so as you can see, students who studied from 0 to 10 hours, not including 10, 5 students, and then 9 students studied from 10 to 20 hours, 20 to 30 hours and stuff like that. So as you can see, it's almost as if it's like a uniform distribution. So what happened here? How come some people just didn't study? Is that what happened? But probably not. It's just they didn't insert their numbers. So as you can see, if I looked at the table itself, you can see some students, they just haven't answered the number of hours studied. It's just probably unknown. So these are the nulls. You could remove them if you want. Sometimes I don't mind keeping them, but right here, I could keep them just for visualization for you, because like it doesn't affect the other columns. All right, so let's look at the distribution for now. So doing visualization is not part of the scope of this course, but I'll still just do it just for fun. So here I'm gonna get a bar chart. And then for the x-axis, I want the number of hours studied. And then for the y-axis, I want the number of students. As you can see, kind of like a pretty uniform distribution. We have students all over, right? Some of them study a lot, some of them do not study a lot. Cool. Now, last question. This is actually an interesting question that you might get usually if you're a data analyst, is like, is there a relationship between their SAT scores or how much the students study? So we can kind of expect that the more hours the student studies, the better their SAT scores will be. Is that true? I'm not sure. There's definitely a lot of different ways of doing it. Most people would just fit a linear regression on their number of hours and also their SAT scores. But for us, we'll use just a quick visualization using kind of like what we did here, bar chart, but on the y-axis, we'll plot the number of hours studied. And then on the y-axis, we look at the SAT scores. So as you can see, the sample size is quite small, so it won't even be statistically significant. But just for the sake of the exercise, we'll still do it. But let's do buckets of 50 instead. So let's just see the counts. Now that it's buckets of 50s, at least you have a little bit more students on each bucket, so it's a little bit more significant. All right, cool. So let's do buckets of 50s. So as you can see, quite uniformly distributed. Now let's look at the relationship between their SAT scores and the number of hours studied. Okay, so what we want to do is we want to select same thing, same column. All right, but instead we care about the average of their SAT score. So SAT math, plus SAT writing, plus SAT verbal as SAT score from same thing as last time. Okay, let's run this. Let's see what we get. Okay, so we get all these numbers, perfect. Okay, remove that, put the SAT. So as you can see, no difference, very little difference for people who studied 0 hours versus people who studied 100 hours. Apparently, it doesn't really matter. Note that the sample size is quite small, and I think there's only one person that studied 200 hours or more. So I don't think you can really say anything about that. But as you can see, for 0 to 150, it's quite uniform, or at least from 0 to 100. As you can see, there's no relationship between the number of hours studied and their SAT scores. Yeah, so one of your hypotheses can be that, the number of hours studied doesn't matter, just purely about intelligence. But we're not sure, because maybe the more you study, the better your SAT scores will be after 100 hours. So as you can see, maybe we can add one more column, which is just the count, just so that we can visualize it better on how many students there are. Okay, see, as you can see, there's only one student there. All right, so that's pretty much it. And yeah, these are kind of like pretty realistic examples of the queries that you would be doing if you worked at like a big tech company. But instead of just SAT scores, maybe you would look at users watch time, depending on what kind of users they are, from which country and stuff like that. Like, for example, a popular analysis to do is comparing countries' user behavior depending on the website. Like, for example, if you work for Facebook, then you could check like, oh, what's their time spent on the product groups. And then you cut that by countries, you group that by countries, and then you might discover that one country is particularly high and you wonder why. And then you could get a lot of insights from that. One of the most interesting insight is that I think there was one country, I don't really remember which one, but one country had a especially high average on groups, and the reason why is because their government has huge censorship in terms of news and media. So the people living in the country had to resort to Facebook groups to actually share real information or real news from each other for each other, so that they can get real information and not just censored information from the government. Very fascinating stuff. But yeah, anyways, so that's pretty much it for group by, and I'll see you next time.